Geometric sequences are, it's a sequence of numbers in which the ratio, and when we're looking at these guys, we're going to refer to ratio as R, okay, remains constant, okay? So if I said something remains constant, what does that mean to y'all? It stays the same, okay? Now, so to find a common ratio, it is found by dividing each term by its previous term. So what that means, in a series of numbers, you'll take one of the terms that are there in that series or that sequence, and you will divide it by the previous number, okay? So it may not always necessarily be a larger number divided by a smaller number, but you've got to remember that it's the term divided by the previous number, okay? So we're going to look at some of those right here. We're going to identify if some of these examples are geometric sequences, okay? And if they are, we'll talk about what the common ratio is. All right, so the numbers in these sequences, we have 2, 10, 50, and 250. Now, if we're looking for the common ratio and we pick a term, let's say 2. If we're looking at 2, guys, it does not have a previous term, so we have to move to the second one, okay? Correct, okay? Now, but they're not all going to be that easily to identify, okay? So here we've got 10. Divide 10 by the previous term, which is 2, okay? 10 divided by 2 is what? 5. So I'm just going to make myself just a little note there, okay? 50 divided by 10 is 5, and 250 divided by 10 is 5. Now, most of y'all picked up pretty quick there on that each of these was divided by 5. Okay, so that tells me, one, was this a geometric sequence?
5.
Was it? Yes. Okay, but now we know that the ratio is equal to 5, or that common ratio is equal to 5. Okay, now we're going to go over to number 2 real quick. We're going to determine if this is a sequence or a geometric sequence, and if it is, what's the common ratio? Okay? All right, so we got 135, 45, 15, and 5. Now, this is one where I told you you're dividing by the previous term. So here, you've got 45 divided by 135. What is 45 divided by 135? It's what? 1/3, okay? Now, if you're using decimals, you need to find a calculator that's going to put these into fractions, because 1, I don't want repeating decimals as your answer. And 2, when we start working with numbers like a 16th, a 32nd, a 64th, you're going to get into some 5 or 6 digit decimals, okay? So here, we're just going to say it's 1/3. Now, we need to check the other terms in the sequence. What is 15 divided by 45?
1/3.
Is it?
Yes.
Okay. What is 5 divided by 15? 1/3. It simplifies or reduces to 1/3. So here, like we said, 1, is this a geometric sequence? Yes. How do we know it's a geometric sequence?
Yes.
They have the same constant R. Okay. And that one for this one was, that ratio was 1/3. Okay? All right. Now, you may see some like 3, guys, if you're looking at 3. A lot of you may think this looks like a pattern. It looks like a sequence. Because what are all of these numbers here? They're all multiples of what? They're all multiples of 6, and if you're looking at it, you're like, 6 goes into 6, 6 goes into 18, 6 goes into 24, 6 goes into 30, okay? But you've got to be careful here to determine if it's that common ratio. So when you're looking at this, what is 18 divided by 6? 3, Okay? So then you may be looking at some of these, and you may be thinking, oh, 24 is divided by 6, but you don't divide it by 6. It's divided by the previous term. Well, what is 24 divided by 18? Is it 1.3? Are y'all sure? Okay. All right. And then what is 30 divided by 24? 1.25. So here, even though this looks like a geometric sequence, because they're all multiples of 6, it is no, because they don't have that constant ratio. Okay? All right. Now looking at 7. Excuse me, not 7. 4. All right, we got negative 14 divided by 7. What is that? Negative 2. Okay, what is 18 divided by negative 14? Or excuse me, 28. Negative 2. And then negative 56 divided by 28? Negative 2. So again, yes. This one, yes. And the constant ratio, or the common ratio, excuse me, is constant, but the common ratio is considered to be negative 2. Okay? All right, I feel like we can look at number 5 and understand that it is a common ratio, but I do want us to look at it because it's not going to be necessarily be a whole number. What is 80 divided by 40? Half. Okay, 20 divided by negative 40? Negative a half. And then 20 divided by negative 10? Negative a half. So know that here, 1, yes, it's a geometric sequence. 2, the common ratio is going to be a negative. Okay? It is going to be a negative. So you guys can put yes. But know that it's negative 1/2. Okay? All right, now we're going to look at something that's still pretty simple, guys. Continuing geometric sequences. All we're going to do, one, is find the next 3 terms in these. Okay? So, to determine the next 3 terms, the first thing that we have to do is find the common ratio. Okay? So here, what's the common ratio from 7, negative 21 to 63? Negative 3. So my common ratio is negative 3. Now, to find those next 3 terms, you basically do right opposite of dividing the previous term. So you'll multiply to find the next terms. Okay? So after 63, what are you going to have? Negative 189. Okay? Make sure that you know that it's going to be negative. Don't end up missing some of these because you don't have a positive or a negative. Okay? The next one's going to be what? 567. And then negative 1,701. Everybody good there? All right, look at number 8. All right, we've got 3,072, 768, and 192. What's your common ratio going to be here? Is it 4? The rest of y'all, did y'all get 4? Give me a thumbs up if you got 4. Give me a thumbs up if you didn't get 4. Again, make sure you're dividing your term by the previous term. Okay? So here, we determined that the ratio was what? 1/4. Okay? Ratio equals 1/4. Okay? So now, as we know that, now we can determine 192 times the 1/4 should give us what? 48? Y'all agree with that? Are y'all sure on that one? Okay. All right. And 48 times the 4th? 12. And then 12 times the 4th will be 3. Good. So to figure out the nth term of a geometric sequence, guys, we're going to use the formula. You all should be familiar with formulas and what they do and their purpose. Okay. The formula to figure out any term within that sequence is A n, and that n is just the nth term. Now, we're going to use the opposite of the exponent right there. Okay? That is the nth term. A to the nth term equals A first term times the ratio with that term that we want to know minus 1. So we're just going to look at what each term or each portion of this equation represents. Okay, guys, the A nth term, all that is, excuse me, I don't want to put that, just the n. Just the n, okay? The n represents the term we are looking for within the sequence. Okay, so if we're looking for the 32nd term like we talked about earlier, n would be 32. If I said figure out the 80th term, 80 would be substituted in for n. Okay? All right, the next one, A1, that is, it's very simple. It's just the first term in the sequence. So whatever number comes first in that sequence, that's all A1 represents. Okay? And then obviously we have the last thing, you guys, and I'm just going to tab over. Obviously, you know, R is what? It's the common ratio. Okay? All right, so for these next few examples, guys, we're going to use the formula, and we're going to find the 7th term within the sequence. Now, I understand that you can probably, once we find the 4th term, you can multiply again or divide and find it fairly quickly to the 7th term, okay? But we're doing this for the purpose of being able to find the 20th, the 25th, the 28th, the 29th term, okay? So, looking here at number 11, guys, we've got A to the nth term. That just means we are now going to be looking for the 7th term. So we'll write that as A to the 7th term equals, now we said A1 represented the first term within this sequence. It's very simple. What's the first term in this sequence? 3. It's that simple, okay? Now that's going to be multiplied by the common ratio. So let's quickly find the common ratio. 9 divided by the previous term, 3, should give me what? 3. And that's going to be raised to the exponent of the term that we're looking for, which is what? The 7th. That's the one we're looking for. It is n, but it's 7 minus what? 1. Okay? All right. Coming down below it, we are still looking for the 7th term in the sequence. So this is going to be 3 times 6, not 6, 3, raised to the power of 7 minus 1 is 6. Okay? All right, now, so next step, we've got A to the 7th, or the 7th term. 3, what is 3 to the 6th power? 2 what?
246.
Try one more.
How did you do that in your head?
7 what?
29.
729. Okay? Now, then, A to the 7th, 3 times that 729. So we know now the 7th term equals 2,000 what? 187.